All right, hello everyone, and welcome back to our video lecture series for Intro Algebra. So today we are going to be switching gears completely, and we're going to be looking at something called a literal equation. So what a literal equation is it is an equation that involves two or more different variables. And we are going to be solving equations that contain more than one variable. So the process for solving a literal equation is the exact same as the process for solving regular equations. So all of those regular equations that you guys learned how to solve back in chapter 3, you're going to be basically following those exact same steps here. The only difference is that obviously we have more than one variable, and you will always be asked to solve for one of them. I will never leave you guessing. You are always going to be told which variable you are supposed to solve for. Now, what that will mean is that all other variables are going to be treated as constants. So you'll add and subtract them like normal, and like you would for a regular number, and you will divide them like a regular number. So you're going to be focused on just one of the variables and getting that one variable by itself, treating everything else like a number. However, the rules for like and unlike terms do still apply. Remember, if the variables are not the same, you cannot combine them with addition or subtraction. So if you have x plus y, you cannot put those together. You cannot combine them because they are unlike terms. They have different variables. So just keep in mind that you cannot combine terms with addition or subtraction that have different variables. You would just have to leave it as x plus y, for example. So we're going to take this equation and we are going to solve it for y. Notice how the directions specifically told you what variable you were supposed to solve for. You will always be told what variable to solve for. So this is the variable that we are getting by itself. Now remember, same rules as regular equations apply. You do not move the equal sign. You should leave the equal sign exactly where it is, and you should be able to draw a mostly vertical line down all of your equal signs. So what we're going to do is when you get a variable by itself, you are going to undo all operations that are being done to it. So the only thing that is being done to y is that we are adding z. So I'm going to undo that addition with subtraction. I am going to subtract z from both sides. So z minus c is still 0. I'm going to leave the equal sign where it is. Y is now by itself. And then over here on the left, we have x minus z. X and z are unlike terms. They are different variables, so you cannot put them together. So what you will have to do is you will just have to write it as x minus z. So then, as long as y is by itself, that is your final answer. So y equals x minus z. So that's basically what we're going to be doing with any literal equation, is we are going to be told what variable to solve for, and we will be treating all other variables like constants, but just keeping in mind like terms. So for example, we're going to take this next equation, and we are going to solve for a. So it just told us that we're supposed to solve this for a. Now there are two different operations being done to a. We are adding this b, and we are multiplying it by 2. Remember, the process for getting a variable by itself is still the same as it always is. So I'm going to undo that addition first. The opposite of addition is subtraction. So I'm going to subtract b from both sides. So b minus b will give us 0. Now left over on the left-hand side here, we have 2a. And then over here on the right, c minus b. These are different variables. They are unlike terms, so we cannot combine them. So I'm just going to write it as c minus b. Now to finish getting a by itself, we need to undo this multiplication. You undo multiplication with division. So I'm going to divide every single term on both sides by 2. So I'm going to take this term, I'm going to divide it by 2. I'm going to take this term, divide it by 2, and this term and divide it by 2. So then 2 divided by 2 cancels out, leaving you with a equals c over 2 minus b over 2, and it is completely fine for you to leave it like that. The big thing is that the variable that you're supposed to solve for is by itself, so that is a good enough final answer. So then for this next one, we are supposed to get k by itself. Hold on, the subtitles froze. Give it a second to catch up, maybe. Okay, I think we might be back in business. Okay, anyway, so we're getting k by itself. So k is, there's a couple different things being done to k. We are multiplying it by 2, and we are dividing by 3m. Give me 1 second. So I'm going to get rid of that division for, just first. So I'm going to undo that divided by 3m by multiplying both sides by 3m. And that will cancel that out. So then left over on the left we have 2k, and then on the right 3m times n is going to be 3mn. Then I'm going to finish getting k by itself by undoing this multiplication and dividing both sides by 2. And that gives me k equals 3 times m times n divided by 2. So then for this next one, remember, it always tells you what variable you're supposed to solve for. So in this case, we are solving for c. Also remember that all numbers and variables always take the signs to their left. So c is what we are getting by itself, and it is right there. And it actually takes that minus sign to its left. So this c right now is technically negative. That means this r is considered separate, and because there's nothing to the left of this r, it is considered positive. So I'm going to get rid of this r by subtracting r from both sides. So when those cancel out, we are left with minus c here on the on the right. And then on the left, we have p minus r. P and r are unlike terms because they are different variables, so I am going to just leave it as p minus r. However, we're not totally done yet, because remember, there is a hidden 1 right here, so c is technically being multiplied by -1. And in the end, we want our variable to only be multiplied by +1. So what I'm going to do is I'm going to get rid of this times -1 by dividing every single term on both sides by -1. So c is now by itself. And then just remember your rules for multiplying, for dividing negatives. So positive p divided by -1 is -1p. And then negative r divided by -1 is going to be positive r. And you can leave it like this, or you could write it as r minus p, whichever. But as long as c is by itself, that is now our final answer. So for this next one, we are supposed to take this literal equation. This is actually the area formula for a rectangle. Area equals base times height. And we are going to solve it for b. So there is hidden multiplication between the b and the h. So I am going to undo that multiplication using division. So I'm going to divide both sides by h. And then that'll be it. So b is now by itself equals a over h. These types of equations are going to be the most common type of literal equation that you're going to solve in this class. There is a really good reason that we are covering this, and you are going to be solving a lot of literal equations when we get to Chapter 7 and we get to graphing. So we're going to take this literal equation, which has x's and y's mixed together, and we are going to be solving for y. So y is what we are getting by itself. And there are a couple of different operations being done to y. So we're going to undo all of the operations that are being done to y. So y is being multiplied by 3, and we are adding a 7x. So I'm going to undo that addition first by subtracting 7x from both sides. So 7x minus 7x cancels out, leaving you with 3 times y equals, now over here on the right, a number with no variable and a number with a variable are unlike terms. So you cannot combine this into -4x. You are going to have to leave it as 3 minus 7x. These are unlike terms. Remember that you cannot combine unlike terms. So then what I'm going to do is I'm going to undo this multiplication by dividing by 3, and I'm going to divide every single term on both sides by 3. So you get y equals 3 divided by 3 is 1 minus 7 over 3x. And it is perfectly okay to leave it like that for reasons that we're going to get to a little bit later on when we get to graphing. You do want the x term first, so you could write this as negative 7/3 x plus 1 if you wanted to. It's not technically necessary. As long as y is by itself, then you're fine, then you have solved it successfully. So what we're going to do for each of these is we are going to get y by itself in each of these literal equations. Keep in mind that a number or variable always takes the sign to its immediate left. So looking at 2x plus y equals 4, if I'm trying to get y by itself, now y isn't being multiplied by anything, which is good, but we are adding this 2x, so what I'm going to do is I'm going to get rid of that plus 2x by subtracting 2x from both sides. So when those cancel out, you're left with y equals 4 and 2x are unlike terms, so you need to leave it as 4 minus 2x. And then that is good enough for a final answer. Now for this next one over here on the top right, again, we need to undo any operations that are being done to y because we're supposed to be solving for y. So y is being multiplied by 3 and we are subtracting 2x. So I'm going to undo that subtraction first by adding a 2x to both sides. So over here on the left, we are left with 3y equals 5 plus 2x. These are unlike terms, so you cannot combine them. And because it's addition, you can swap the order of addition if you want to write it as 2x plus 5. Then I'm going to undo this multiplication using division, so I'm going to divide every single term one at a time on both sides by 3. So now y is by itself equals 2 over 3. You can leave it as 2 over 3x plus 5 over 3. You can leave it as 5 over 3. So then for this next one over here on the bottom left, remember that a number always takes the sign to its left. So if we're getting y by itself, y is being multiplied by a negative 7. And then we have this minus 4x over here. So I'm going to get rid of the minus 4x first. The opposite of negative 4 is positive 4. So I'm going to add 4x to both sides. So then we get negative 7 times y is equal to negative 14 and 4x are unlike terms, so you need to leave them separate. Negative 14 plus 4x. Then I'm going to finish getting y by itself by dividing both sides by negative 7, and I'm going to divide every single term one at a time by negative 7. So y is now by itself here on the left, and I'm just going to divide each term one at a time by negative 7. So negative 14 divided by negative 7 is positive 2. And then positive divided by negative is a negative. 4 over 7 does not reduce, so you can leave it as 4 over 7x. And as long as your variable in question is by itself, that is your final answer. So then for this last one over here on the bottom right, we're supposed to get y by itself, so y is being multiplied by negative 2, and we are adding this 5x. So I'm going to get rid of the 5x first by subtracting it from both sides. So 5x minus 5x cancels each other out, leaving you with negative 2y equals, now over here on the right, 6 and minus 5x are unlike terms, so we are going to leave it as 6 minus 5x. Then, to finish getting y by itself, I'm going to divide both sides by negative 2, and I'm going to divide every single term on both sides by negative 2. So y is now by itself equals positive 6 divided by negative 2 is negative 3. Negative divided by negative is a positive. 5 over 2 cannot reduce, so you're going to just leave it as 5 over 2x. And we're going to make sure, before we really go using this in Chapter 7 extensively, that we are really good at solving these literal equations like this. Always keep in mind that a number takes the sign to its left. So looking at 5x minus 6y equals 12, I'm supposed to get y by itself. Y is being multiplied by negative 6, and then this 5x is technically positive. So to get rid of this 5x, because it is currently positive, I'm going to subtract it from both sides. So over here on the left, we are left with negative 6y equals 12 minus 5x. These are unlike terms, so you're going to leave it as 12 minus 5x. Then I'm going to finish getting y by itself by dividing every single term on both sides by negative 6. So that gives us y equals positive 12 divided by negative 6 is negative 2. Negative divided by negative is a positive 5 over 6x. And if you want to, you can also rewrite that so that the x term is first. You can also rewrite it as y equals 5/6 x minus 2. Now for this next one over here on the top right, we're supposed to get y by itself. So I'm going to first get rid of that 9x, and since it is currently positive, I'm going to subtract 9x from both sides. So 9x minus 9x cancels each other out, leaving you with negative 8y equals 8 and 9x are not like terms, so you cannot combine them. So I'm just going to leave this as 8 minus 9x. Then I'm going to finish getting y by itself by dividing every single term on both sides by negative 8. So then y equals positive 8 divided by negative 8 is negative 1. And then negative divided by negative is a positive 9 over 8x. And you can leave it like this. This is fine. If you want to, you can also rewrite it as y equals 9 over 8x minus 1 if you want to or need to. So for this next one over here on the bottom left, y is being multiplied by 4, and it is, hold on, I don't know what I did. Okay, so y is being multiplied by 4, and we are adding 6x. So I'm going to undo this adding 6x by subtracting 6x from both sides. So then we get 4 times y is equal to 12, and minus 6x are unlike terms, so you need to leave it as 12 minus 6x. Then to get y by itself, we're going to divide each term one at a time by 4 on both sides. So we'll get y equals 12 divided by 4 is 3. And then, minus 6 over 4, yeah, it's a fraction, but please reduce it. 6 over 4 can reduce to 3 over 2x. So please reduce it. And then for this last one over here on the bottom right, if we're trying to get y by itself, y is being multiplied by 4, and we are adding a positive 7x. So I'm going to undo that addition using subtraction. I'm going to subtract 7x from both sides. So that gives me 4 times y equals, now 14 and minus 7x are unlike terms, so you cannot combine them. Do not put them together. So you're going to have to leave it as 14 minus 7x. Then you're going to finish getting y by itself by dividing every single term on both sides by 4. So y is going to equal, now 14 over 4, yeah, it's a fraction, but please do reduce it. 14 over 4 can reduce to 7 over 2. Minus 7 over 4 cannot reduce any further, so y equals 7 over 2 minus 7 over 4x is a good enough final answer. One of the reasons why you solve literal equations is formulas. All formulas are literal equations because in order to be a literal equation, it just has to involve 2 or more different variables. Formulas have 2 or more different variables, so all formulas are technically literal equations. And what you can do is you can solve a formula for one of the variables and rewrite it in terms of all of the others. So let's take this formula for example. So the formula P equals 2 times parentheses L plus W is the formula for the perimeter P of a rectangle in terms of its length L and its width W. So what we're going to do for part A is we are going to take that literal equation and we are going to solve it for L. Now if you notice, the variable that you're trying to solve for L is currently inside of a parenthesis. Remember, to clear out parentheses, you use distribution. Sorry, the subtitles are glitching out. So to get rid of the parentheses, I'm going to distribute, so I'm going to distribute this 2. So 2 times L is 2L, and then 2 times W is plus 2W. And remember, we are trying to get L by itself, so again, don't move the equal sign. L is being multiplied by 2, and we are adding 2W. So I'm going to get rid of this plus 2W first by subtracting 2W from both sides. So over here on the right, we're left with 2L, and then over here on the left, I have P minus 2W. Remember, P and W are unlike terms, so we cannot put them together. So then I'm going to finish getting L by itself by dividing each term on both sides by 2. So that will give me L equals P over 2. And then minus negative 2 divided by 2 is negative 1W. So L is equal to P over 2 minus W. Now you might be thinking, why in the world did we just do that? Well, for part B, let's say that we know that the perimeter of a rectangle is 20 centimeters and its width is 6 centimeters, and we want to find the length of the rectangle. So when we solved that formula for L, we got a formula for L in terms of P and W. So all you have to do to find the length of this rectangle is take this formula that we solved for L, plug 20 in for P, and 6 in for W. So I have L equals, in for P, I'm plugging in 20 over 2, minus in for W, I'm going to plug in 6. So then when you simplify this, 20 over 2 is 10, minus 6, you get L equals 4. Alright, so for this last one, oh come on, why aren't the subtitles going? Ugh, give me a second. Alright, so for this last one, we have V equals L times W times H is the formula for finding the volume of a solid, where L represents the length, W the width, and H the height. So what we're going to do for part A is we are going to solve this formula for H. I think the subtitles have just totally stopped working, so hopefully the subtitles that YouTube provides are going to be sufficient. I'm very sorry. I don't know what's going on with this. So we're going to solve this formula for H. Now H is being multiplied by both L and W. So to undo multiplication, you are going to use division, so I'm going to divide both sides by both L and W at the same time. You can do that because one division will undo both of those multiplications, so you can absolutely do that. So then we get H equals V divided by L times W. So this is now that volume formula rearranged for H. So what we're going to do for part B is we are going to now use that formula to find the value of H, given that the volume is 48 cubic feet, the length is 8 feet, and the width is 2 feet. So what we can do is we can use this given volume, length, and width to find the height of that solid. So we have H is equal to 48 is getting plugged in for V, over 8 is getting plugged in for L, and then 2 is getting plugged in for W. So we can only divide two numbers at a time, so we're going to do that 8 times 2 first, so we get 16, giving us H equals 48 divided by 16 is 3 feet. So that means the height of that solid would have to be 3 feet. Alright, and that is actually it for literal equations, so make sure that you get plenty of practice, especially for the type of literal equations where you have x's and y's mixed together and you're getting the y variable by itself. So hopefully YouTube subtitles are sufficient, because I think mine just broke and I don't know why. So I will thank you all very much for watching, and I will see you in the next video with hopefully less technical glitches. Thank you. Bye.